Alright guys, welcome to this set of notes. These videos are going to be all of the videos that go along with Chapter 2, Section 1 out of your textbook and follow the notes for Chapter 2, Section 1. What we're going to be doing here in Chapter 2 is really we're going to be looking at everything you did in Algebra 1 when it comes to linear functions. Alright, relations, functions, linear functions, and graphing them. We're going to start by just describing, going through, reviewing everything having to do with what is a relation, and is a relation a function, and how you determine that or figure it out. You're going to have two objectives or learning targets in this set of notes. These are the things you should be able to do. The first one is going to be able to analyze a relation or a function. We're going to show you a number of different ways of visually representing a relation, and then once you have visually represented that relation, figuring out, does it represent a function? So we're going to start off by looking at all of that. After we get done doing that, we are going to spend some time reviewing how we then take these relations and functions, put them into a graph. So when I say use equations of relations and functions, anytime you're given an equation, generally in algebra, we're either going to be asking you to solve it or I'm going to be asking you to graph it. We're definitely, since we did solving in the last chapter, we're going to start looking at graphing here in this chapter. So we're going to be doing some graphing. Let's go ahead and jump right into it. So here we go. Slide this up. When it comes to a relation, what I've told you is a relation essentially is a set of ordered pairs. What I'm going to highlight for you is just simply this. You should remember from Algebra 1, the domain is the x values and the range, let me do it in this color, the range are the y values, all right? Domain is x values, the range is y values. Please don't get those confused as we go through these problems. In almost every problem, I will ask you to state the domain and I'll ask you to state the range. Also, very important, let me point this out as well. Remember that the x values, the horizontal axis, the x values are the independent variable, all right? We choose a value of x. The y values, or the domain values, the vertical axis, are the dependent variables because they depend on x. I choose a value of x, I plug that into my function, and the function tells me what my y value is. X is independent, the y value depends on the value of x that you've chosen. We'll go over all that more when we actually get to the graphing part. Now, as I stated, there are going to be a number of different ways to visually represent a relation. Let's go through them here. The first one is going to be writing the relation as a set or set notation. What this is it's just going to be a list of ordered pairs. All right, so we have a list of ordered pairs. And remember, the reason that we call them ordered pairs is because they come in a specific order. It's called an ordered pair because the order is always x, then y. So it is x, comma, y. That is our ordered pair, x first, then y. And of course, then if we were to do it domain and range, it would be domain first, then range. Domain, and then the range. Put those in. So when I ask you to put your relation into set notation, you will just simply write out the list of ordered pairs that represents your relation. The first value in the ordered pair will be all of your x values or your domain values. The second value in each ordered pair will be your y value or your range value. Now what I can do, the second way to represent a relation, is to take those ordered pairs and put them into a table or a chart. I really don't care which you call it, table or chart. I may even use those terms interchangeably as we go through the year. In one problem I might call it a table, the next problem I might call it a chart. Sorry if that kind of freaks you out. I think they're the same thing. So what we'll have is we'll always have the x values on the right-hand side. We'll always have the y values on the left-hand side. And I prefer, and I hope you, please put them in increasing order. Smallest value at the top, going down the list, increasing his value in value as you go. So my first ordered pair is -2, 1, so -2, the y value is 1. Then -1, 0, so -1, 0, 0, 1, 0, 1, 1, 2. Actually, that is a typo. I apologize. It's a good thing we checked these. That should be a 1, not a 2. So 1 and 2. Now, when it comes to these, please do not repeat values. All right? Do not repeat values. We'll see this in a second when we get to the example problems, but let's just say, for example, I had another ordered pair that was 0, 3. All right, I'm not going to repeat a value in my table, okay? You don't want to repeat any value. So since the 0 already appears in the x column, I don't want to write it twice. You only want to write it once. That'll be true for the other ones as well. Okay, here we go. I have for you the next way to show or represent a relation is going to be in a map. What this is going to be is it's going to be taking your table, all right, that table that we just did on the last page. You're going to write the domain values, right? These are all of my domains. Go back and check the previous page. These are domain. These were the range values without any duplicates. Please do not write the repeats. Sorry, I'm writing domain again. These are my range. And I apologize. I apologize. On this, when you do the table, you will have repeats in the table, right? The 1 shows up twice. And that is okay because you're representing an ordered pair when you do the table. Where you do not want repeats, where you're not going to repeat values, is when you do a map. I'm very, very sorry about that. Please scratch what I said before. In the table, you may have repeating values. Here we will not, right? Please notice I did not write 1 twice. Since the 1 is already there, I'm only going to write it once. Don't repeat values when you do a map. So do not repeat values. Do not include, let's say, duplicates. Do not include duplicates. Do not include duplicates, all right, when you're doing the map. Now, the way the map is going to work is you're just going to rewrite the values from the domain and the range. You can put an oval around them most of the time because I think it's a little easier to draw. I'll just put a rectangle around them, and then we'll simply draw arrows from the domain value to the range value that it is associated with. All right, that's the third way. So we have set notation, we have a table or a chart, you have a map. We'll get a lot more practice doing those. And then finally, the fourth way to do this is going to be by graphing them, right? And you guys know how to graph ordered pairs. It's x comma y. So you find the x value first on the horizontal axis, you find the y value on the vertical axis, and you plot your point. Again, when it comes to the domain and range values, I may ask you to state the domain and range values, which you would simply do right there. Just go ahead and state the domain and range values. Again, all values of x, please do not include the duplicates. So when stating the domain and range, no duplicates. Sorry, I forgot my E up here, squeezing the E up there, and no duplicates. Right up here, here, let me. erase it. I'll just go over it. ES duplicates. Okay, so anyway, again, please, just no duplicates. All right, now here's what we're going to do. Now that we know how to write a relation in the 4 ways, which we'll get practice with in just a second, I also need you to be able to figure out whether the relation represents a function. And that's what we're going to take a look at right here. So let me slide this table up. Let's go ahead and highlight what a function is. All right, so a function are mathematical relationships in which the elements of the domain is paired with exactly one element in the range. Now let's go ahead and take a look at a couple of these which are shown to you in the chart, because there's more than one type of relationship between the domain and the range values. So here we go. And I will ask you to determine which one of these you actually have. We'll get practice with this in a second. The first one's going to be a one-to-one function. Now what's happening here is we're talking about the domain values going to the range values, all right? And here's the way it works. As long as every element in the domain, we're talking about the domain, as long as every element in the domain goes to a unique range value, that means that 1 doesn't go to both D and B. Right, it can't go, the domain values can't go to 2 places in the range. Each domain value must go to 1 range value and 1 range value alone. If that happens, your function is 1-to-1. Is 1-to-1. All right, so this is domain values go to 1 range value. Oh, that's my highlighter. Hold up. Each domain actually, I apologize, I'm not going to write it. It is written right here for you. There it is. Each element of the domain pairs to exactly 1 unique element in the range. It's written right there for you. The other type of relationship that you can have is an onto relationship or an onto function. And this one is talking about the range values going to domain values. So this is opposite, right? This one was domain going to exactly 1 value in the range. This onto says each element in the range, right, corresponds to exactly 1 element in the domain. It would be onto if that were true. And then what you'll have is this both 1-to-1 and onto. Let me highlight it for you. Both 1-to-1 and onto is going to be if both cases are true. Each element in the domain pairs to exactly 1 element in the range. It would also be onto if each element in the range pairs with exactly 1 element in the domain. And again, we'll see this when we get to a couple of example problems. So go ahead and take a second look at this. You should be familiar with 1-to-1 and onto from Algebra 1 and probably even pre-algebra as well. We'll go ahead and do some example problems on the next page. So if you want to head on over there, I'll meet you there.